All right, 5.3 we will split up into two parts. First part is we'll do double angles today. We'll do half angles then the following day. So whenever we talk about double angles, okay, we have double angle formulas for sine, cosine, and tangent. Okay, so if we have sine of 2 theta or 2 times theta, all that's going to happen is the 2 is going to come out in front, and then we're going to split up sine of theta as sine of theta times cosine of theta. Whenever we have cosine of 2 theta, or double of our angle, I'm going to have cosine squared theta minus sine squared theta. So it's a lot like whenever we had our trig identities. The biggest difference, obviously, or hopefully it's obvious, that we have cosine squared minus sine squared instead of the two numbers adding together. The last one then is tangent of 2 theta. If you think about really any of these as if we would write the sum or the difference formulas and we would add two angles that are the same, essentially that's what we're doing from the previous day before. So like whenever we had tangent of alpha plus beta, we would have tangent of alpha plus tangent of beta. Well, the two angles are the same, so that's why we have two of them. Same way with tangent of, on the bottom side of the denominator, where we had 1 minus tangent of alpha times tangent of beta. Alpha and beta are those same angles, so it's really just tangent squared. So whenever we go about this, if I have sine of theta equal to 5 over 13, and theta lies in quadrant 2. So then again, I need to know as far as what's positive, what's negative, as far as sine and cosine. Obviously sine's positive, but cosine is going to be negative since we're dealing with quadrant 2. So before I do anything, I need to know what x, y, and r are. So if I have x, if I have y, and I have r, hopefully 13. Sine, so sine deals with y, and that is 5. So then I need to figure out what x is, use Pythagorean theorem. 13 squared minus 5 squared equals x squared. 169 minus 25 equals x squared. 144 equals x squared. So it's going to be negative 12 because it lies in quadrant 2. So it's negative 12. So then I need to go to my formula. So it's sine 2 theta. So then I'm just going to go with my formula for sine. So I'm going to have 2 times sine of theta, cosine of theta. So then 2 times, now I just replace my value for sine, so 2 times 5 over 13 times cosine of theta, which is going to be negative 12 over 13. Then I just begin multiplying. So then whenever I multiply, I'm going to have negative 120 over 169, and nothing can reduce, so we're just going to leave it as is. Going on then to cosine of 2 theta. Same setup, just different formula. So it's still going to use the same values because we didn't change anything. We're still using the same angle that I had before. So whenever I go with cosine of 2 theta, all I'm going to do is have cosine squared theta minus sine squared theta. So I'm going to take my angle, square it. So cosine is negative 12 over 13. I'll square it minus sine squared theta, so I will take my 5 over 13 and square it. Again, you're going to have the same denominator, so everything's going to be nice and neat. I'm going to have 144 over 169 minus 25 over 169. 144 minus 25. I'm going to have 119 over 169. Last one, then I will go with tangent of the double angle for tangent. So it is 2 tangent of theta minus 1 tangent squared of theta. So 2 times, here, let's write that out. So it's 2 tangent of theta divided by 1 minus tangent squared theta. So 2 times sine over cosine, or y over x, so times negative 5 over 12 divided by 1 minus, same thing squared, negative 5 over 12 squared, and then just go from there. So negative 10 over 12 over 1 minus 25 over 144. So once you get to here, I reduced the 10 over 12 and I subtracted 1 minus 25 over 144. It's really up to you. Some students will want to do just keep, change, flip and just go 5 over 6 times 144 over 119. That's completely fine with me. It really doesn't matter as far as how you do it, to be perfectly honest with you. It's really, like I said, it's completely up to you. So if once I do that, then all I'm going to end up with is a negative 120 over 119. Now, with the second example, it says find the exact value of 2 tangent of 15 degrees divided by 1 minus tangent squared of 15 degrees. Don't overcomplicate this. This is just the formula that we already have. Basically, we already have that tangent of 2 theta is equal to 2 times tangent of theta divided by 1 minus tangent squared theta. Okay, x, theta, alpha, beta, whatever representative you want to use, it's going to all be the same. So realistically, all I'm doing with all of this is really just taking tangent of 2 times 15 degrees. Well, 2 times 15 degrees is just tangent of 30 degrees. So then, again, we're going to give you values that are going to be easy to use. Okay, tangent of 30 degrees will just give you a value of square root of 3 over 3. Now, how do we know that it's a square root of 3 over 3? Well, it's the smaller. If we use a trick with our hand, and 30 degrees is right here. So as far as my sine and my cosine is the square root of 3 over 2. Sine is 1/2. So again, just take 1/2 divided by the square root of 3 over 2, and I get 2 over 2 square root of 3. Well, 1 over the square root of 3 will simplify to the square root of 3 over 3 whenever we rationalize it. All right, there are then three forms of double angle formulas for cosine of 2 theta. Different ways you can write that. The majority of the time, the reason why you want to do any of these three is mainly if you want to, like we already talked about this one here, but everything else then is going to give you different ways as far as to go about it, more for whenever we are verifying, okay, and how we can verify things a little bit different. I'll talk about verifying whenever I get back on Friday, so instead of doing it through the video, we'll just talk about number 3 on Friday.